Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on complex analysis, power series lecture number 4, in which I will give the technique to find the domain of convergence of power series. Now I will solve a problem. Problem is examine the behavior of the series sigma n equal to 2 to infinity z to the power n by n under bracket log n whole square. Since here a n equal to 1 by n log n whole square and a n plus 1 equal to 1 by n plus 1 log n plus 1 whole square. Therefore 1 by r be the radius of convergence, equal to limit n tends to infinity a n plus 1 by a n modulus, and this equal to 1 by n plus 1 log n plus 1 whole square by 1 by n log n whole square, and this is will be equal to n log n whole square by n plus 1 log n plus 1 whole square. Dividing numerator and denominator, by n we get, here we also use the modulus. In this step no need to use modulus, all are non-negative terms. 1 by r equal to log n whole square by 1 plus 1 by n. If we divide this by n, here 1, here 1 plus 1 by n, limit n tends to infinity. Here we take common n 1 plus 1 by n whole square. This is equal to limit n tends to infinity log n whole square by 1 plus 1 by n. Here we take log n plus log 1 plus 1 by n whole square equal to limit n tends to infinity log n whole square 1 plus 1 by n. Here we take common log n. Log n. Here remains 1 plus 1 by log n. Here log 1 plus 1 by n. whole square equal to limit n tends to infinity. Here log n whole square, here 1 plus 1 by n, here log n whole square, log n whole square, here 1 plus 1 by log n. Here we expand this 1 by n minus 1 by 2n plus dot 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 whole square. Here log n whole square cancel. Only remains limit n tends to infinity 1 by 1 plus 1 by n under bracket 1 plus 1 by n log n minus 1 by 2 n log n plus dot 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 whole square. Here using n tends to infinity, we get 1 by r equal to right side 1 by 1 plus 1 by n is 0, n tends to infinity. Here under bracket 1 plus 1 by n log n, n tends to infinity, this is 0, this is 0, all terms are 0 whole square, implies that 1 by r equal to 1, implies that r equal to 1. Therefore radius of convergence equal to 1. This is a circle whose center is z equal to 0 and radius of convergence r equal to 1 and the center of the circle be z equal to 0. Therefore the series is convergent at every point inside the circle of radius 1 and center be z equal to 0. Since mod z equal to 1 represents the points on the circumference of the circle and sigma n equal to 2 to infinity z to the power n log n whole square modulus equal to sigma n equal to 2 to infinity modulus of z to the power n log n whole square. Since modulus of z is 1 equal to sigma n equal to 2 to infinity 1 by n log n whole square, which is convergent by Cauchy condensation test. Therefore, given power series is absolutely convergent at the points within the circle and on the circle whose radius is 1 and center is z equal to 0. Now we solve problem number 2. Problem is find the domain of convergence of the power series sigma under bracket iz minus 1 by 2 plus I whole to the power n. Here un equal to iz minus 1 by 2 plus I whole to the power n and un plus 1 equal to iz minus 1 by 2 plus I to the power n plus 1. Now limit n tends to infinity un plus 1 by un modulus equal to limit n tends to infinity I z minus 1 by 2 plus I whole to the power n plus 1 by I z minus 1 by 2 plus I whole to the power n modulus, and this is equal to limit n tends to infinity modulus of I z minus 1 by 2 plus I whole to the power 1. Here to the power n, here to the power n plus 1. This will be equal to limit n tends to infinity modulus I z minus 1 means plus I square. Here 2 plus I. This equal to limit n tends to infinity I common z plus I. Here 2 plus I modulus, and this is equal to limit n tends to infinity modulus of I modulus of z plus I modulus of 2 plus I. Here no term contains n, so we may write here this equal to modulus of I equal to 1, modulus of z plus I, and modulus of 2 plus I is 2 square plus 1 square square root, and this is equal to modulus of z plus I by square root 5. Let this is number 1. We know that the series is convergent if limit n tends to infinity modulus of un plus 1 by un less than 1. This is number 2. Using 2 in 1, we get, this is limit n tends to infinity, modulus of un plus 1 by un, modulus of z plus I by square root 5 less than 1 implies that modulus of z plus I less than square root 5. This is number 3, which means the series is convergent at the points within the circle which center is z equal to minus I and radius is square root 5. Now we solve the next problem. Problem is find the domain of convergence of the power series sigma under bracket 2I by z plus I plus 1 whole to the power n. Now we solve this. Here un equal to 2I by z plus I plus 1 whole to the power n and un plus 1 equal to 2I by z plus I plus 1 whole to the power n plus 1. Now limit n tends to infinity, modulus of un plus 1 by un equal to limit n tends to infinity, modulus of 2I by z plus I plus 1 whole to the power n plus 1 by 2I z plus I plus 1 whole to the power n, and this is equal to 2I by z plus I plus 1 modulus. Here we have no n, only here n plus 1, so only remains 1 power, and this will be equal to 2 modulus of I modulus of z plus I plus 1, and this will be equal to 2 modulus of I is 1 and here z plus I plus 1. Left side is limit n tends to infinity, modulus of un plus 1 by un. That this is number 1 and this is modulus here. Since the series is convergent, if limit n tends to infinity, modulus of un plus 1 by un less than 1. This is number 2. Using 2 in 1, we get 2 by z plus I plus 1 modulus less than 1 implies that 2 is less than modulus of z plus I plus 1. implies that modulus of z plus I plus 1 is greater than 2. This is number 3. 3 represents that the series is convergent at the points outside the circle whose center is z equal to minus I plus 1 and radius is 2. Here this is a circle whose radius is 2 and center is z equal to minus I plus 1. These points are outside the circle. The series is convergent at these points. Points of convergence. These are points of convergence. The series is not convergent within this circle. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.